Okay, let us start the class. So in the previous class, we have discussed about the highway alignment and about the different points through which a highway alignment should pass and about the different points through which a alignment should not pass. Now you know about the different points and different characteristics of the alignment. Now the important question is how you will decide about the points. Okay, how you will go for the groundwork. So this thing can be done with the help of engineering survey for the highway alignment. Now this engineering survey is divided into four parts, and these are map study, reconnaissance survey, preliminary survey, and final location and detail survey. Okay, now these four parts which is given over here, this is in order. These are given in order. So for example, map study is the first and foremost thing which you have to go for. After that you need to go for the reconnaissance survey. Then after you can go for the preliminary survey, and after that you will go for the final location and detailed survey. Now, map study. Now, as the name suggests, this map study is basically the study of the map. So, for a particular area, suppose two cities are there where you need to construct some alignment, so that entire area you need to study through some map which is available over there. These maps are called topographical map. Now Google Maps are also available. So from the topographical map you will locate different features of the area, and after carefully locate all the features from the map, you will finalize some alternative routes. Suppose 5 to 6 numbers of or 5 to 10 numbers of alternative routes through which your uh, ultimate alignment should passes. Now you will get different details from this map study, like the natural and artificial features of the area, and accordingly you will suggest different alternative routes. Now the probable alignment can be located on the map from the following details available on the map. So these are the details which you need to look for the map study. First one is avoiding valleys, ponds or lake. So this valley, ponds and lake, this can be easily available in the map, so you can easily locate them. Avoid any bending of the river. This can always easily be located in the map, and you can easily avoid the bend of river. And if road has to cross a row of hills, possibility of crossing through a mountain pass, you will check whether is there any possibility that your alignment can go through a mountainous pass. Okay, so these are all the important things which will go for the map study. So after the map study, you will finalize 5 to 7 numbers or 5 to 6 numbers of alternative routes which will be reduced in your next portion or next step. So our next step is reconnaissance survey. So in the next step, what will happen? You have already decided different alternative route, 6 to 7 number of alternative routes. Now you will assign some surveyor to survey through these uh, 5 to 6 routes, and this surveyor will be carrying with some very basic instrument, okay, like leveling stuff or compass like that, and they will uh, look for the other details which will be present over the site. And this is second phase or second step of the survey. Now, the rough survey is done along the alternative proposed route in the map study and find out their ultimate aim is to find out the feasibility of each and every alignment which were suggested in the map study. Now, this reconnaissance survey is conducted to confirm features indicated on the map, whether the features which are indicated in the map they are correct or not, to examine the general character of the area in field for deciding the most feasible routes for detailed studies. Now, a survey party may inspect along the proposed alternative routes of the map in the field with very simple instrument like leveling staff, tangent clinometer to roughly get an estimate about the curves, etc., to collect additional details. Okay, so after the reconnaissance survey, what will happen is, suppose initially you have decided seven alternative routes. So after the reconnaissance survey, you will reduce or trim some of the alternative routes based on the feasibility condition, and ultimately, suppose now you have three to four alternative routes after the reconnaissance survey. Now, the details which need to be collected from this reconnaissance survey are valley ponds, lakes, marshy lands, hill and permanent structures which are available over that area. Then value of the gradient, that's why that leveling stuff is required. Length of the gradient and radius of the curve. Okay, that is the rough estimate. You do not need that exact value, but a rough estimate to get an idea about the topographical features of that area. Then number and types of cross-drainage structures, that is what is the number of the cross-drainage structures and what are the different types. It may be a small stream, it may be a river, so you need to take a note of this. Then high flood level. So basically this is also important because based on the high flood level, the elevation of your road will be decided. Now if a particular portion of the area, if that high flood level is very much high, in that case you need to avoid that portion. Otherwise, in maximum time of the year, your road may be inaccessible due to the accumulation of the excess water due to flood. Then soil characteristics. This is also important because based on the soil characteristics, the construction of the pavement will be done. Then geological features, different geological features like stability of the slopes, whether hilly area or plain area, etc., you need to look for. Then a rough idea about the availability of the construction materials like stone quarries are available or not, water sources are available within a short distance or not, etc. So, from the details collected during the reconnaissance, the alignment proposed after the map study may be altered or even changed completely. So, whatever you have suggested during the map study, you can alter after the reconnaissance survey, or you can trim some of the alternative routes. So, as a result of the reconnaissance, a new or a few alternative alignment may be chosen for further study. So, suppose after the reconnaissance survey, you have decided upon three to four alternative routes. Now, you will go for the detailed survey on that particular route. So, after the reconnaissance survey, you need to prepare a report based on the merits and demerits of each of the alternative routes with a scale of 1 in 50,000. So this is reconnaissance survey. So next portion is your preliminary survey. So in the preliminary survey, this is the third step of the engineering survey. So in this step, the alternative routes which are proposed after a rough survey in the second step are surveyed in details. So whatever routes you have suggested in the reconnaissance survey, that all these routes will be studied with some details in the preliminary survey. Now, the objective of the preliminary survey is to survey the various alternative alignments proposed after the reconnaissance and to collect all the necessary physical information and detail of topography, drainage, and soil so that you can compare all the alternative routes based on their merits and demerits. As in the report of the reconnaissance survey, it is required to prepare a report based on the merits and demerits of particular route. So after the preliminary survey also, you need to make some report discussing all the merits and demerits of different alternative routes. To compare the different proposal in view of the requirements of the good alignment, you know the factors, that is alignment should be safe, easy, okay, economical. So that factors you need to consider for the highway alignment, and you need to look for whether all these components are satisfied in a particular alignment. To estimate the or to quantify the artwork requirements or artwork materials which are required for the construction aspect. Now there are different methods of the preliminary survey. So first one is conventional method. So in the conventional method, a surveyor team will go to the field and uh, survey the different alternative routes. Okay, now this procedure of the survey is listed over there. So first one is traversing. Now the traverse is run from the starting point to the end point by setting out different control points. So you know about the traversing. Suppose points A and B is there. So you will go along the suggested alternative routes in the reconnaissance survey, and you will set different points by traversing. The both primary traverse and secondary traverse may need to be run. So along this traversing route, that is primary traversing point and secondary traversing point, you need to check the leveling work which is required for that alignment. Now the leveling work is carried out along the central line or the proposed route which you have already decided based on the traversing. Now the leveling work is used to estimate the volume of the earthwork. Okay, so both in the horizontal direction and both in the vertical direction. Okay, so you need to uh, calculate what is the ultimate leveling work which is needed for the different alternative routes. Then topographical features. Topographical features means, is there any type of geographical and man-made features which are available along that area? Okay, then also you need to look for it. Then drainage studies and hydrological data. Now the number of cross drainage structures are estimated during the preliminary survey. So how much cross drainage structure you need to construct along that particular route. So for each and every alternative route, you need to calculate all this data. After that, you will compare different alternative routes. Then soil survey is done to know the basic characteristics of the soil. So basically based on the characteristics of the soil, different features of the road will dependent on that is how much construction material is needed. Okay, what should be the strength of the pavement, or what should be the width of the pavement or depth of the pavement. That is all uh, estimated from the soil survey, because on the soil only you will construct your pavement. So if the soil is not stable enough, it is weak, in that case the construction material requirement of the construction material would be very much higher. So in that case also you need to go for the soil survey. Then material survey means whether the construction materials are easily available along with that alternative route. Then traffic survey means how much number of vehicles you are expecting to use that particular route. So that thing also you need to consider. Then determination of the final center line. So after collecting all this data, that is traversing, leveling work, topographical features, drainage studies, and hydrological data, soil survey, material survey, traffic survey. So these are all the parameters. After carefully study all these parameters along each and every alternative routes, you will compare different alternative routes, and ultimately you will decide which alternative route is best suited for your final alignment. Okay, so you will propose one particular route for the final alignment study. Now these are the some specification of the survey which uh, you need to follow during this survey procedures. So for the longitudinal and cross-section profile, that is leveling work. For the plain terrain, it is 100 to 200 meter interval, that is the traversing. Then for the rolling terrain, that is slightly hilly portion, that is 50-meter interval. And for the hilly terrain, that is 30-meter interval. That is the your different control points which you need to set on the ground. So this is basically the conventional method for the preliminary survey. So again, I will discuss this. In the conventional method, some survey team will visit different alternative routes which is suggested by the reconnaissance survey. So after that, they will collect different parameters, and based on that parameters, they will decide which route is best suited for your alignment. So ultimately, so first in the map study, there was map study. Suppose in the map study, they have decided 5 to 10 alternative routes. In the reconnaissance survey, uh, they get a rough idea about different alternative routes, and they trim 5 or 7 alternative routes. So ultimately, there will be 3 or 4 alternative routes. So in the preliminary survey, they will go for more detailed survey along that 3 to 4 alternative routes, and ultimately they will decided upon one particular route. Now along this particular route, okay, so this is the conventional method. Now for the preliminary survey, there is some modern or rapid approach is also there. So in the modern or rapid approach, you do not need to go in the field. So how it is done? The procedures of the modern rapid approach is this one: taking aerial photographs with required lateral and longitudinal overlaps, and these aerial photographs can be taken by the drones. Now drones are available, so from the drones you can easily take the photographs or easily visualize along with the routes. So in that case, you do not need to go in the field for the preliminary survey. Now these photographs are then examined under stereoscopes, and control points are selected for the establishment of the traverse. Now whenever you are taking the photographs, you need to take them within some scales, and you need to mention that scale so that after a careful examination of the uh, required photograph, you can have an idea or rough estimate about the topographical features of the area. Now, different levels and contour line may be obtained from the stereoscopes. Okay, stereoscopes pair. So, for that reason only, to know the exact amount of the leveling work and contour, you need to take the photograph within a certain scale. Now, photo interpretation method is used to grab information on the geological features. So, this is some electronic features whether that electronic software will read the photographs, and from that photograph they will decide different geological features. So, they will extract different geological features from that portion. Now, based on this, a report should be prepared, and this is the scale for that. For the hilly terrain, in horizontal, the scale should be 1 in 1000, and in vertical, it should be 1 in 100. For the plain and rolling terrain, it would be 1 in 2500, and for the vertical, it is 1 in 250. So, ultimately, the last step, okay, last step for your highway alignment is final location and detailed survey. So in the final location, whatever ultimate road you have decided on the preliminary survey, you need to go in the field with some advanced instrument, surveying instrument, and go for the detailed survey. Detailed, that is, that survey should be very much accurate, okay, along that particular route. Now, some of the points which is decided on the final location and detail survey. So in the final location and detail survey, that is part into two components. First one is final location survey, then detail survey. So first thing is you need to locate the uh, proposed alignment over that road. So for this, transferring the alignment onto the ground, and that can be uh, done by transit theodolite, and this method is called traversing. That is, you will set some different alternate control points over the route along the proposed alignment. That is, major and minor control points are established on the ground, and central line is marked with some pegs. Okay, and checking the geometric design requirements. So whatever alignment you have proposed, so through that alignment, by traversing, you need to establish the central line. Okay, and that central line is marked through pegs. Now, central lines tracks are driven at suitable interval, and that interval is, say, 50-meter interval in plain and rolling terrain, and 20-meter in the hilly terrain. Okay, so that distance you need to maintain, that is the maximum one. Okay, you need to maintain whenever you are putting some control points. So basically, that is the distance between the two control points. So by this way, you will ultimately locate your alignment in the ground. So after that, detailed survey. So in the detailed survey, temporary benchmarks are fixed at intervals of about 250-meter, and a tall drainage and underpass structures. So in that case, temporary benchmarks are fixed along that route, and you need to consider about the different drainage and underpass structures. Then earthwork calculation and drainage details have to be worked out from the level. So you know the leveling works. So from the leveling works, you have to decide about the cutting and filling required for that elevation. So from that you will have a idea about the earthwork requirement for that area. Then cross-sectional levels are taken at intervals. So these are the different intervals, different specification. I think I do not need to discuss about all these things. Then details oil survey. Basically, it is soil survey. Details soil survey is to be carried out. Then severe value of the soils along the alignment may be determined for the design of pavement. Now this severe is California bearing ratio test. Now this severe test is conducted to know the strength of the soil. So along your alternative route, you need to collect the soil sample for the severe test, which will be very much important in this designing your pavement. Now, the data during the detailed survey should be elaborate and complete for the preparing of the detailed plans, design and elements of the project. So basically, as this is your final survey, so all the data which you have collected, they need to be very much accurate. Okay, exact elevations, exact curves, each and everything should be mentioned in the detailed survey. So basically, after the detailed survey, the construction work will begin. So all these parameters which are considered in the detailed survey should be very much accurate. So this is the highway alignment, engineering survey for the highway alignment. Now the next portion is necessity of realignment. Sometimes what happen, one existing road is there, but you need to realign that road. So what are the different causes of the realignment? So first one is improvement of horizontal alignment such as super elevation, transition curve, side distance, etc. Suppose one particular route is there, and in that road there are excessive rise and excessive fall, that is, and side distance means visibility ahead of you or visibility ahead of a driver whenever he is driving his vehicle. Suppose that visibility is very much low, in that case it will lead to some accidents. So in that case you need to go for the realignment for that entire route. Then improvements of vertical alignment design elements like steep gradients, changes in summit curves to increase side distance, correction of undesirable undulation, etc. So for the vertical curves and gradients that I have already discussed, that if there is excessive rise and excessive fall, some undulations is there, in that case also you have to go for a possible realignment of that road. Raising the level of a portion of a road which is subjected to flooding. Now suppose one particular portion of the road is there, and that portion of the road during a maximum period of time or considerable period of time, that portion of the road got submerged in the water. Okay, and it remains a very much inaccessible during that particular period of time. So in that case also you have to go for a possible realignment of the road. Then reconstruction of quick and narrow bridges. Suppose you need to go for the reconstruction of narrow bridges and quick bridges. In that case also you have to go for the possible realignment of the route. Then construction of overbridges or underbridges at suitable location across a railway line in place of level crossing, or across another road to provide grade separation intersection. Suppose some intersection is there, some railway crossing is there. If you want to go for the grade separation, that there may be some overpass, there may be some underpass, so in that case also you can go for the possible realignment of the route. Then realignment required due to the portion of the route being submerged underwater at the reservoir area. Suppose you have construct one dam and the reservoir area there have some roots, but that reservoir area got flooded because of the dam. So in that case also the portion of the route which got submerged, you need to realign that route so that that route remain accessible for the use. Then construction of bypass to avoid the road running through a town or city. Suppose one of the national highway is there and that go through a particular city. Now during the daytime, what will happen? That portion which passes through particular city, that portion will be very much congested. And if any traffics are there which just need to go from one portion to another, just want to cross that city, in that case it will create different problems. So in that case also you can construct some bypass route so that the portion within the city can be avoided. Then defense requirement, if there is some defense requirement, you need to construct any road. So this is all about your engineering survey for the highway alignment. So do you have any confusion? This is very much important. So just go through the notes, just have a look in the material and tell me whether do you have any confusion or not. Is it clear? Okay. Okay. So if any doubts come up, just discuss with me. And about the attendance, please give the attendance whoever was not present in the previous class. Yes, this session is offered. Yes, you can leave. I think all of you have given
Think all of you have
attendance.
given attendance.
Hello, sir.
Yes.
Yes.
Do we need to give attendance again?
If you were
If
present in the previous
you
class,
were
in that
present in
case,
the
do not
previous
move.
class, in that case, do not move.
Okay. Thank you, sir.
Okay.